Okay. So when it comes to a problem like this one, what do you do? Keeping the force of 400 Newton acts perpendicular to an inclined plane ABC as shown. Determine the moment produced by a outcome A. Express the result with the result as a Cartesian vector. So this is 3D. What in 3D? In this case, you have to build Cartesian vector. And you get the moment in 3D. It's easier to obtain the moment by crossing the displacement vector from the point from the expressed to a point along the direction of the force. Then cross this with the force vector itself. This is the easiest approach to getting the moment. So I want to get the moment of the force state about the force state is this one. The point A is here. Now, what are we seeing? Pay attention to the kind of information that is indicated. I think this is a act, this positive act perpendicular to the plane. So if this force is perpendicular to the plane, what does it mean? It means that it's perpendicular to the line. You see, it is also perpendicular to the line AC, such that it creates a right angle with this line. You also create a right angle with that line. This is what we have. Based on this, see, that knowledge is important for us. We get the knowledge of the positive output using variables that we need expressed vector. The most linear value in this case is a vector from A. Any point was fast. Really was fast. So we get this vector is we also this vector was vector. The force in vector form. So we've got no displacements in that direction, mostly with displacements to obtain vector, obtain the now for no displacement in that direction. This is what the video comes into play. Let's get the displacement vector RIC phase. This is straightforward. You run A to C, just like on this one. Which is what? And the x-axis, the y-axis, the z-axis, so that all that and then we see, and we see the x look y, that's first of all, and z. So this is the average fine as initial, we are going up to C. So in the x 0, initially it was as this is so let's draw the next one. Let's translate all this that we have let's start with the x. This is the x-axis. This is the z-axis. And this is the y-axis. You're right. And shape that. I'm explaining to you is not that. Then I also want to repeat how the was talking. So the x1 z the point C is right along the y-axis. Since it is on the z-axis, then clearly already should take x0 there, y0 there. The only thing that changes for the point A is the fact that if you have the z x is 0 there, y is 0 there, all z are bad because we have three units there. So same thing you look at the point C lies on the y-axis. And on the y-axis, x is 0, and z is 0. So let's see, we are looking at 0 x sample and 0 z. How far y-axis is the four steps. So in can try to predict what's the answer. What are they? Yes. Or that is correct. So let's proceed then. Now that we see how to obtain the coordinates, we can use the educated displacement vectors. So the x coordinates when these are going to see it will be this 0 minus that 0 the next for the y coordinates and c plus 4 and a plus 0. Then we go to the z coordinates. At C, we have 0. At A, we have 3. So that the displacement vector AC will be 0i 4j minus 3k. So we'll obtain the displacement vector. But now the problem is this second piece, this second detail, we have no idea how to get it, or it seems not so clear. Well, we then recall one thing. If you had a plane, and this plane contains two vectors, A and B. You should recall that whenever you get the cross product between two vectors, the vector you get is going to be a vector that is perpendicular to the plane containing the vector A. So the cross product of these two will be a vector perpendicular, both vectors perpendicular to B and perpendicular to A. That is what you get. What am I getting at? By the same logic, if we can get, we sort of say that the question says the force is perpendicular to the plane. And by that, it is perpendicular to the displacement vector run this way. It will also be perpendicular to the displacement vector to run that way. Implying that if we can get the displacement vector R now around CA and the displacement vector R CP. If we can get these two displacement vector and cross them, so crossing here, of course, CA cross CP. When I cross these two, what I will get will be another displacement vector, but this displacement vector will be the direction of the force. Since the force is perpendicular to both RCA and RCB, it means that even this displacement vector will have to be perpendicular to these two by properties of cross product. So I need these two displacement vectors. Well, luckily, we already have RAC. RCA is the opposite of that by sign at least. So, or you can obtain it the standard way, but you still find that RCA will be minus. So we now just need to find RCB. For RCB, we already have the coordinates for B and the coordinates for C. That is our A, our CME, and our B. So RCB will be, final is at B, so we'll have 3 minus 0, 0 minus 4, and 0 minus 0. So we'll have 3I minus 4J. After obtaining this, we can now cross them. To cross them, we can use the cross product or the determinant method. We have I, J, and K. Which one am I starting with? I said I'll go with RCA first, which is minus 4 plus 3. It has no I, so I have 0. Next, TB, 3 minus 4. Any questions up to here? So from here, we know how this works. We get I. We'll have minus 4 by 0, that's 0 minus 3 by minus 4, that will be minus 4. So making this positive 4. Then minus J, 0 by 0 will be 0 minus 3 by 3, that will be 9. Then we get K, 0 by minus 4, that will be 0. 3 by minus 4, that will be minus 12, but will be minus here, it will be plus 4. Any questions there? Okay, so this vector now shares the direction that our force has. So now we can get the force in vector form. The force in vector form can be written as the force itself. The force has magnitude of 400 newtons. Remember, we need the force and the unit vector that run in the direction of the force. Since we have the displacement vector in the direction of the force, a unit vector in that direction can then be obtained. It's the vector itself divided by its magnitude. So what will be the square root there?
.2.
D, 2, 1. So now we can divide this into 400 and multiply. So that f will be equals to what will be the x component. I'm saying this divided by this. So 400 divided by 19.21, 4. Okay. Okay, so that is 400 by 4 divided by 19.21. So we have 249. Eight, 7, 9 plus, then we have 9 by 400 divided by 19.21. Now we get 187.4J. K is also true, so it will give us the same thing as for I, which is 249.87. Okay. So this becomes our force in Cartesian vector form. When we're looking for that force, remember the force was not the goal. The force was the goal was the moment due to that force about A. So now we have the force in vector form. So we need to use it here. We already know RAC. RAC is this. And now we know the force as well. So we easily get the moment. The moment of the force about A will be obtained using the determinant method. What comes first is the displacement, 0 under I, 4 under J, minus 3 under K. And then from the force, we have 249.87. And then we have 187.4 under J for the force, and 249.87. Now we can get the moment. When we get I, it's going to be 4 by 249. So that's 4 by 249. And minus, but there's a negative there again, so it will end up being plus in the end. 3 by 187.4. So this is 1, 5, 6, 1. Then we get minus j. When you get j, it's 0 times 249.87. That will be 0. Minus, then there will be a negative coming, so it will be positive. But it will be 3 by 249.87. We get 749.61. Then we get k. Again, have 0 by 187, that will be 0. Then minus 4 by 4 by 249.87, which is 999.48. So I hope you guys are verifying through what I was doing there. So a moment becomes I j and minus. This looks as good as 1,000. We can keep it like this. Okay. What units were we using? The 400, the force had what units? Yeah, newtons. The lengths are meters. So this will be the Newton meter. So this becomes the moment in a Cartesian vector form. The question did specify even express the result as a Cartesian vector, which is what we have here. So this is how you were supposed to work out this. And a question